We have a couple more problems to look at. So the graph of f prime is above. Find the intervals where f of x is concave up, and find the x values where f of x is a point of inflection. So when we are looking at this graph, we need to remind ourselves what we have. So we have f prime of x. If we wanted f double prime, we would need to take the derivative or look at the slopes. So what we're going to be doing is looking at the slopes of this function in order to determine the concavity. So if I'm looking at this graph right about here, everything on this side, our function's slope is increasing. So our slope here is positive. Everything on this side, our slope is negative. If our slope is positive, that means our concavity is going upwards because second derivative would be positive. If our slope is negative, our concavity would be downwards because our second derivative would be negative. So we are concave up on x less than 1, and that's because f prime of x, the graph that we have, is increasing. So notice here I said f prime of x is increasing, not f of x. If we're talking about f prime increasing or decreasing, that's giving us information about the second derivative. We are concave down on x greater than 1 because f prime of x, our slope is negative, is decreasing. When we look at our graph where our slope changes from positive to negative, this would also be when our second derivative changes from positive to negative. So at that point where it changes, that point 1, we have a point of inflection. So f of x has a point of inflection. At x equals 1 because f prime of x changes from increasing to decreasing. Okay, f double prime of x is equal to the quantity x plus 2 cubed times x minus 1 squared. Find any x values where f of x has a point of inflection. So looking at this function, I need to set it equal to 0. It's a polynomial, so we know it won't be undefined. So I know -2 and 1 are my x values where our second derivative is 0. So now I just need to check to see what is going on with our second derivative. So I'm going to pick some values that are around it to see what happens. So if I plug in -3, -3 plus 2 is -1. That being cubed is going to make it -1. -3 minus 1 is still negative, but it's squared, so that's going to be positive. A negative times a positive would be a negative. If we plug in 0, 0 plus 2 would be a positive. 0 minus 1 is going to be negative, but squared, it's a positive, so we have a positive times a positive. And then our last one, 2. 2 plus 2 is 4. Cubed is still going to be a positive number. 2 minus 1 is negative 1. Squared, 2 minus 1 is 1. Squared is going to be a positive number, so this is positive. So a POI, or a point of inflection, only happens when our sign changes in our second derivative, either from negative to positive or positive to negative. Looking at this, the only time we have a POI is at negative 2. And that's because f double prime of x changes sign at x equals negative 2. In our last problem here, we have the graph of h prime of x is above. On what open intervals is h of x decreasing and concave up? Give reasons for your answer. So this time we need the first derivative and the second derivative. So we need decreasing, which is when h prime of x is less than 0. In our case, with our graph, this is going to mean y value of our negative. Concave up means that h double prime of x is greater than 0, and in our case meaning the slopes are positive. So if we look at our graph, everything below this line is going to be decreasing. So decreasing is down here. We also need our slope to be positive. And what I like here, our slope is positive here and here. So everywhere else I can kind of ignore in order to kind of answer this question. So when I'm looking at this, or even looking at it overall, I might be increasing on this whole interval right here, but that's the only part that's above or below the y-axis or the x-axis. So our final answer for this is going to be h of x is decreasing and concave up. On, I'm going to use when x is between 2 and 5 and 8 and 9. And that's because h prime of x is negative and increasing. So we needed h prime of x to be negative, but also increasing.